I thought I would read from the Wikipedia page on 0 to the power of 0. It's all spelled out that way. That's the title of the article. The intro paragraph. 0 to the power of 0, denoted by 0 to the 0, is a mathematical expression with no agreed upon value. The most common possibilities are 1, or leaving the expression undefined, with justifications existing for each, depending on context. In algebra and combinatorics, the generally agreed upon value is 1, whereas in mathematical analysis, so the place where you use limits to figure out everything, the expression is sometimes left undefined. So, like, when you're stupid and you think that limits are all there is, that's when you leave it undefined. That's the subtext here. Computer programming languages and software also have differing ways of handling this expression. Now, notice, already we're at a point where if it has a value, the value is 1. Discrete exponents. Many widely used formulas involving natural number exponents require 0 to the 0 to be 1. For example, the following 3 interpretations of b to the 0 make just as much sense for b equals 0 as they do for positive integers b. What about negative integers? Anyway, the interpretation of b to the 0 as an empty product assigns it the value 1. The combinatorial interpretation of b to the 0 as the number of 0 tuples of elements from the b element set. There's exactly 1 0 tuple. The set theoretic interpretation of b to the 0 is the number of functions from the empty set to the b element set. There's exactly one such function, namely the empty function. All 3 of these specialize to give 0 to the 0 being 1. Yada 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 yada, bloop bloop bloop. Okay. Continuous exponents. Limits involving algebraic operations can often be evaluated by replacing sub-expressions by their limits. So I kind of showed this incorrectly the other day. But I feel like I showed it well enough that fuck it, it's fine. If the resulting expression does not determine the original limit, the expression is known as an indeterminate form. Okay, let me read this again. Limits involving algebraic operations can often be evaluated by replacing sub-expressions by their limits. If the resulting expression does not determine the original limit, the expression is known as an indeterminate form. Let me break that down. Can often be evaluated means that they can't always be evaluated by this method. If the resulting expression does not determine the original limit, that is, if it's not evaluable this way, then the expression is known as indeterminate. So if using limits fails to yield... if using limits fails, and you can't get an evaluation for it, that's all that the indeterminate form means. It means that it failed. It doesn't mean that there isn't a value for it. It just means that you can't find the value this way. That's all it means. And this is the only reason anybody has a question on what 0 to the 0 is. Because of this shit. The expression 0 to the 0 is an indeterminate form. Given real valued functions f blah blah blah, fuck this, okay. Yeah, just details, it doesn't matter. Okay. Complex exponents. In the complex domain, the function z to the w may be defined for non-zero z by choosing a branch of log z and defining z to the w as e to the w log z. This does not define 0 to the w since there is no branch of log z defined at z equals 0, let alone in a neighborhood of 0. Yay! So again, this really just doesn't speak on the matter. This doesn't mean that it doesn't exist. This just means you can't find it this way. Okay, so, okay. History as a value. In 1752, the oily pack of lions, Leinhard Euler, in Introductio Why is it in fucking Latin? Wasn't he German? Or... Anyway. Introduction to Analyzing Infinities. He wrote that a to the 0 is 1. And explicitly mentioned that 0 to the 0 is 1. An annotation attributed to Mascheroni in 1787's edition of Euler's book, it's a different book, offered the justification 0 to the 0 equals the quantity a minus a raised to the power n minus n. And that is the same as, this is kind of what I showed you, but the other way. A minus a to the n over a minus a to the n equaling 1. Yeah. So this is actually, but I showed it the other way, because I actually justified 0 to the 0 being 1 first, and used that as justification for why anything over itself is 1. But we have to be careful, because it has to actually be the same thing over itself. In the case of 0 on 0, that's not 1, or it can be, but it's not 1 always, because it's not necessarily the same thing divided by itself. It appears to be because we're lazy in the way we write it, but it's not actually. When you get inches divided by inches and that disappears and goes to 1, you have inches raised to the 0 power. That's not a number, it's not even a vector, it's just the unit component. So it is absolutely unambiguously something divided by itself. And normally when you're doing conversions like this, you know, like you're fiddling around with, say like you're adding fractions, and you multiply by, you know, so you have like, you multiply by something that would be 1 because it's something divided by itself. There's no units on that, so it is literally the number divided by itself that works there. 0 on 0 often is not that. It's often actually, there's a vector on the top and a vector on the bottom, but you're not noting the units, so it looks like it's 0 divided by itself, but it really isn't. They're different things. Yeah. Anyway, apparently, these were far from convincing. Well, yeah, because you're doing it backwards. Even by standards of rigor at the time. It's amazing to me that nobody's actually just said, oh wait, fuck, if exponentiation is iterated multiplication, then there has to be a starting point, and that starting point must be 1 because we're multiplying. And that starting point is the 0th position. That 0th power is the... Like, I don't understand how there's any other way to look at this. How is this confusing to everybody for fucking centuries? I don't get it. How is nobody seeing this? What? Holy shit. And then there's all of these blah blah blah. I'm not going to read all that. Current situation. Boom. Some authors define 0 to the 0 as 1 because it simplifies many theorem statements. That's a stupid fucking reason. I mean, like, I get it, but it means that you don't understand what's happening. According to Benson, 99, whoever the fuck that is, the choice whether to define 0 to the 0 is based on convenience, not on correctness. If we refrain from defining 0 to the 0, then certain assertions become unnecessarily awkward. The concession is to use the definition 0 to 0 is 1, although there are textbooks that refrain from defining 0 to 0. Okay, so what? That's just an admission that you don't know what's happening. So it's funny to me. It's funny to me when people like this argue with somebody who actually provides a solution, and they're like, no, you don't understand. Clearly you don't understand, dipshit. What? And then Nuth in 1992, and I think I agree with him, let me see, contends more strongly that 0 to the 0 has to be 1. Yeah, I agree with that. He draws a distinction between the value 0 to the 0, which should equal 1, and the limiting form 0 to the 0, which I also do. which is an indeterminate form, because the limit doesn't fucking matter. It doesn't tell you anything about the value, because the limit never evaluates it. It never does. It never gets to the point that it evaluates it. It's a limit. You can get arbitrarily close, but you never actually evaluate it. And because things like discontinuities and holes and whatever the fuck exist, and we know this, we know that we cannot trust limits. So anyone who's sitting on their high horse saying, oh, but the indeterminate form means we don't know what the value is a fucking retard. Anyway, other authors leave 0 to the 0 undefined because 0 to the 0 is an indeterminate form, which is fucking retarded. There do not seem to be any authors assigning 0 to 0 to a specific value other than 1. Right, so anyone who is actually needing a value, they're in a situation where it has to have a value, that value is 1. And anyone in a situation where they're like, oh, hey, let's just play make-believe and kind of try to get as close as we can to it and see what happens in their all circumstances, but we don't really care what the value is. They're getting indeterminate. Okay? But they're not evaluating it, and they're not needing a value. Nothing's right. Nothing's right here. 0 to the 0 is 1. The limiting form 0 to the 0 is indeterminate, but that's fucking irrelevant. It doesn't matter. That doesn't matter to the value of 0 to the 0. And the fact that this is even an issue is absolutely amazing to me, because this is so fucking stupid. You can trivially grow out exponentiation from, as I've shown, from incrementation to addition to multiplication to exponentiation, and show that for it to properly grow as an iterative process of the step previous to it, you have to have an initial starting point, and for exponentiation, that initial starting point is obligatorily 1. And that initial starting point of 1 defines everything to the 0th power, including 0. The base is irrelevant because the base doesn't come into play because it's the starting point. It's before you ever use the base for anything. Holy shit. And this also explains why, when you actually have something divided by itself properly, you get 1, but why when you have a casually written 0 over a casually written 0, and this is actually vectors, these are the two components to a vector, it doesn't give you 1. Right? 1 foot per 1 second also doesn't give you 0. It gives you 0 feet per second. Or it doesn't give you 1, it gives you 1 foot per second. Right? The unit thing, the unit doesn't change. The units, they don't disappear. Right? So 1 foot per 1 second. Make sure I said this right, because I'm doing it in my head and I fucked it up. I know I fucked it up. 1 foot per 1 second, right? So you got 1 over 1, that's 1, but it's feet per second. Right? The feet per second, you can't make that go away. 0 feet per 0 seconds. What is that? Okay, the problem here is you can't convert it to any feet per second because your denominator is 0, which means that it's vertical. Your vector is vertical with respect to what you can see. So you can't see what's happening there. Right? It's blocked off from your view. You can't tell what happened. Right? Because you're... yeah. 0 on 0 is not 1. Sometimes it's 1. It can be 1. It can be anything. But it's not definitely 1, because it doesn't operate as a function. 0 to the 0 doesn't have the same problem. It doesn't have the same problem at all. 0 to the 0 is totally fine as a function. It works perfectly fine as a function. There's no issues. What the fuck are we doing? Holy shit.